From my earliest days in the anatomy lab, I've always enjoyed tracing the connections between humans and other members of the animal kingdom. And those ties sometimes present themselves in unexpected places.
When I walked into the anatomy lab for the first time, I was sort of scared about what I was going to see, what I was going to feel. But the reality is, after the first few weeks, that fear turns into a sort of a cocky self-confidence. And these things, you know, when you dissect them, it doesn't look very human. It kind of looks like a wax model in a lot of ways because it's been preserved. But then you hit the hand. And for me, as I unwrapped the gauze and revealed the palm, the fingers, the fingernails, something else hit me entirely. And that was a deep sense of connection, a connection to another human body lying on that slab. This was not a wax model that I was dissecting. This formerly was a person who lived a life just like I am living now.
The structure of the hand is remarkable and complex. Its muscles, tendons, and bones allow us to shape the world around us. But it turns out this basic structure is not unique to humans. In fact, it points to our connections with other animals. By the 19th century, scientists were documenting the similarities among the limbs of vertebrates.
Sir Richard Owen was an anatomist back in the 19th century. He was fortunate to be an anatomist in an age of discovery. And so people were coming back to London with new and oddball creatures for him to analyze. And in analyzing all the different creatures that were brought to his laboratory, he found common patterns.
Although the shape and structure of each limb was very different, Owen started to see an underlying unity. It was as if the same set of bones was being squashed or extended to perform different functions.
Here's a dog. Dogs, run and jump. What do you have? One bone, two bones, little bones, and then the digits, the equivalents of the fingers or toes. And, of course, here's a bird. It flies. Its limb has been modified into a wing, and it has one bone, two bones, lots of bones, and then digits. The amazing fact is, in each of these creatures, the architecture is largely the same as ours. Owen didn't know why creatures had that pattern. It was a mystery to him. It was sort of a mystical concept that there's this common architecture behind all animals. It really took a new insight, an insight from Charles Darwin, which basically said the reason why animals have this common pattern is because at some time in the distant past, they all shared a common ancestor that had a version of this pattern too.
As far back as 375 million years, we've found fossil evidence of a creature that has this pattern. It's fish-like, and it's just beginning to make the move onto land. My team found one of these transitional animals, called Tiktaalik, after 6 years of exploring an island in the Canadian Arctic. Remarkably, its fin had the beginnings of the one bone, two bones, many bones, and digits pattern. It's good evidence that the basic form of this complex and quintessential piece of human anatomy, the hand, emerged from the fins of ancient fish.